Okay. Okay, so on the previous page, we said to memorize the Pythagorean identity, sine squared t plus cosine squared t equals 1. And from that, you can figure out the rest of the identities as long as you know the other identities. You've got to memorize stuff. Quizlet out there to help you. So if cosine t is 2/3, it will use the Pythagorean identity to find the value of sine. So we just substitute 2/3. Now this is a little weird. We write, this means sine of t squared, but we shortcut it and put the squared here. So sine squared t plus 2/3 squared equals 1. And we're gonna square this and solve for sine. And then we'll use a quotient identity to find tangent. So we're going to square that, sine squared t, plus we square the 2, we get 4, and we square the 3, we get 9, equals 1. Now we're going to subtract 4/9 from both sides. You can do that on your calculator, but 1 is 9/9, so that's 5/9. So sine squared t equals 5/9. And then we're going to take the square root of both sides. We're going to get the sine of t equals, and did it say where it was going to be? Oh. I have a note on my copy that we're restricting t to be between 0 and pi/2. So sine and tangent are positive. So when you take the square root of both sides, we usually do a plus or minus sign. But because we're restricted to this domain, then we're going to use just a positive number. So it's the square root of 5/9, and you can separate that as square root of 5 over the square root of 9 is square root of 5 over 3. So sine t is the square root of 5 over 3. So that's one of the answers. And the other answer, we're going to use a quotient identity. This you need to memorize. Tangent t equals sine t over cosine t. So now we've got the square root of 5 over 3 over 2/3. And I think I lost some of you last time, so let's write that out. It's the square root of 5 over 3 divided by 2/3. And then the rule is to flip. We change this to a multiplication, flip the second fraction. Square root of 5 over 3 times 3/2. And so the 3's cancel, and you get the square root of 5 over 2. And so if you understand that this is how it's going to work, you could cancel the 3's here and skip some steps. That's what I did in class the other day. Okay, but All right, and the unit circle shows the repetitive, and we're going to get the unit circle out in a minute, repetitive or periodic nature of the trigonometric functions, and the pattern of values repeats such that f of t plus the period equals f of t. The period is like for sine, and it's 2 pi. It's before it repeats itself. This is one, it keeps going, but it's repeating. That's the period. This is sine t. So, sine of t plus 2 pi will just equal sine of t. And cosine of t plus 2 pi will be cosine of t. And tangent repeats itself every pi. So tangent of t plus pi will just be tangent of t. And cotangent is the same as tangent in terms of period, so it's t plus pi. So the period for tangent and cotangent is pi, while the period for sine and cosine is 2 pi. And I'm gonna see if I have some. I don't think there's any pictures. So there's the periodic. They don't show you the pictures. Okay. So tangent looks like this. This is minus pi over 2. This is pi over 2. Sorry, that's pretty free, but anyway. So it's got a period of pi, and cotangent is moved over 1, and cosine looks like this. I have these memorized, and it just depends where you start, but cosine looks like this. This is 2 pi, and then it repeats. Depends what part you draw. Okay, and so if we want to find the value of each trigonometric function, and we want to find cotangent of 5 pi over 4. Let's see, are we starting to use the unit circle here? Well, okay. We got a cotangent of, we're going to use what we just learned, cotangent of pi over 4 will be equal to cotangent of pi plus pi over 4. And that equals 5 pi over 4. And then I'm going to use the fact that cotangent is cosine over sine. So that's cosine of pi over 4, sine of pi over 4. And we found those last time to be square root of 2 over 2. Square root of 2 over 2. And so that's 1. I can get the unit circle out. You know, we made, and I skipped a bunch of steps, but we made a picture. If this is 45 degrees, or pi over 4, same thing, then these sides are equal, and we found this point here. by taking, the Pythagorean theorem says that this side squared plus this side squared equals the hypotenuse squared. Well, in the unit circle, that's 1. So that's where we went through a squared plus a squared equals 1. So that's 2a squared equals 1, and divide by 2. A squared is 1/2, and then we take the square root of both sides. So a is 1 over the square root of 2, and then we rationalize it, and we get the square root of 2 over 2. And that's how we found those using the Pythagorean theorem on the unit circle there. So that's what cosine, that's what sine is. You got to remember that cosine of t on the unit circle is just the x value. So on a unit circle, and sine is y. That's on the unit circle. Okay, and then there's another one, cosine of minus 9 pi over 4. Okay, so I'm going to do the work over here. I really need to redo these notes and make them bigger. Not enough room. We're going to work this one. Well, this cosine is an even function, so this equals cosine of 9 pi over 4. Oh, 4. Because it's even. An even function has f of x equals f of negative x. We learned that in 1710. So cosine's even, so cosine of a negative angle, it's just going to be cosine of the positive. And then cosine has a period of 2 pi. We can rewrite 9 pi over 4 as cosine of pi over 4 plus 2 pi. That's 2 pi is 8 pi over 4, that's 9 pi over 4. And that's periodic. We just said that this, anytime you're adding 2 pi to the angle, that's all the way around the circle. So that just equals cosine of pi over 4. And we just showed you that that was square root of 2 over 2. So we used the fact that cosine function's even, and then we used the fact that it's periodic, and its period is 2 pi. And I actually, but on my notes, I actually drew some pictures to show you. Let me get some, here's some paper. So it may be helpful to draw a picture of 5 pi over 4. So this is pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, and 5 pi over 4 is there. That's where 5 pi over 4 is. And we've got, this is the square root of 2 over 2. And we're gonna fill out that unit circle in a second. Okay, so we went to there, and we have positive values here, but this is the third quadrant. We're going to have negative values. The point over here, it will be negative square root of 2 over 2, negative square root of 2 over 2. So if Remember, cotangent was cosine over sine. If you divide two negatives, you can get a positive. That's why this was equal to that. If we're dividing two negatives, we still get positive 1. Okay, so you can draw the picture to figure out why is cosine pi over 4, which stops here, the cotangent, I mean, why is that equal to cotangent of 5 pi over 4? Okay, so thinking about it visually there, and draw the other one. 9 pi over 4 will go all the way around the circle, and then it goes all the way around the circle once it stops here. And this is square root of 2 over 2. And that's 9 pi over 4. So if you draw the picture, you can see visually why these are equal. So that should be helpful. Okay. All right. So, let me hand out this unit circle. I did make copies. Okay. This is the one for you to fill in. You don't get to use the unit circle on every test, or what if you want to draw one yourself? There's a trick to drawing it. Did you have, oh, you made it, you don't want to do it, okay. There's a trick to doing it, you want to.
Oh, sure.
You can. We got 6 people. You got one and you already made it? Oh, right. You want to do it again? No? Well, you got 5, there's 6. If you want to do it. You don't have to. You got one too? Oh, okay. All right. So we're just going to fill this in. It's a trick to filling this in. Did everybody get one that wanted one? This came out dark because I had it on green paper. So I copied it. Now some of you came in late, and I need to get you on the attendance. Let's see. Did Brittany come in? No. Lauren? Coach? Couch? Alex, did she come in? No, the other Alex. We have 2 Alexes in this class, sorry. Brady Quillen, did you come in? And Nathan, I think I saw you. That's why. Okay. Okay, so the trick to fill this out, well, first off, what's this point? This point is 1, 0. Oh, can you see that? Okay. And I have 0 degrees equals 0 pi equals 2 pi right here. Okay, and of course you have 0, 1, and then all of these are fractions, and they're all divided by 2. And then you can count 1, 2, 3, and 1, 2, 3. And then you have to add the square root sign. So square root of 3, you have to add the square root signs over these. And of course, if you take the square root of 1, you get 1. So that's a unit circle. Let's see, this is pi over 2, or 90 degrees. And then you can just take that and, well, I didn't mark this. Okay, this is 30 degrees for pi over 6. This is 45 degrees. Pi over 4. Should have this memorized. 60 degrees. Pi over 3. And now that we've got that, we can do the rest of the circle. If you're in quadrant 4, you know, so we can just add the right negative signs in. So we can, and this is 0, -1. So we're going to be dividing all these by 2 again. Oh, you can see that. 2, 2, 2, 2. We have to add the negative signs in. It's 1, 2, 3, 1, 2, 3. Okay, and you have to take the square roots of all of these. So there is a pattern. You know, and this is negative 30 degrees or whatever. This is 360 around the whole thing. Oh, what are the signs then? Okay. In the fourth quadrant, x is positive. This is negative. X is positive. This is negative. Yeah. So we had to add the negative sign. And that's how that goes. You can keep going. Remember, in quadrant, this is quadrant 4, and quadrant 3, they're both negative. So, and the other thing you can do is, this is a 30-degree angle here. And I know that 30-degree angle is a ratio of 1 to 2 here. So, anyway, I've got it. I had filled in my second quadrant first. Let's fill in the second quadrant. So, it's, we got to divide by 2. Divide everything by 2. And then we do have to start here. Sine is the y coordinate, and this is a 30-degree angle here. It's going to be 1/2. If the radius is 1, then the sine's be 1/2. That side is always, this side is always half the hypotenuse on a 30 degree. So this would be 1, 2, 3, 1, 2, 3. And then we take the square roots, and we're going to have to put the negative signs where they go. And so we're in the second quadrant. So x, the first coordinate is negative. The second coordinate is positive. So here we're going to have, oh, and this is -1, 0. Here we want, our sign has to be -1/2, because I know that's a 30-degree angle. So I start with 1 there. We're dividing by 2. And 1, 2, 3, 1, 2, 3. got that right. Does that make sense? Yeah, okay. And then we have to add the signs and square roots. And in the third quadrant, X and Y are negative. So we gotta have negative signs on all of these. And then you can fill in the angles, but that's how you fill in, that's a trick to filling in the unit circle. So, any questions? It helps to know the relationship between the 30-degree angle to make sure, you gotta make sure you're starting right with where to start with 1, 2, 3. I mean, we know the 45, definitely. Gotta make sure you get the, you know, square root of 3 over 2 is longer than a half, so that can help you too. And remember, cosine x, so our cosine of t is the x coordinates, and sine of t, if t is our angle, is the y coordinate. And we can make little triangles to make sure we get it right. We got it right. You guys that already did it, right? We got it right. Okay. All right, so that's the unit circle. For part of the test, you get to use your calculator and the unit circle, but the first part of the test is no unit circle, no calculator. So some people like to quickly sketch their unit circle. Is everybody done copying?
Can we bring like a blank one?
Can you bring a blank?
So I can test.
Oh, like, sure, you can bring a blank one. Already a circle, so you don't have to draw it. Yeah. You can have a blank one. Okay. All right. So now that we talked about the unit circle, maybe these will make a little more sense over here. So we've got 23. We can move a ray around the circle an infinite number of times, so we can rewrite the periodic nature as sine of t plus 2 pi n equals sine of t. And then same thing with cosine. Let me just get it in here. Cosine of t plus 2 pi n, where n is an integer, and it can be negative. Cosine of t. And then tangent and cotangent, same way, except now tangent of t plus pi n, since the period is pi, equals tangent of t. Same thing with cotangent. Where n is an integer, it can be negative also. We can go in a negative direction. Okay, so we're going to find sine of 120. So I drew a little picture. I've got my unit circle here. This is 60 degrees. This is 120. 60 degrees and 120. So from the picture, sine of 120 degrees is just sine of 60. Sine of 60 degrees from our unit circle is square root of 3 over 2. Or we'll be showing you how to find those with the triangle too. But yeah, that was 120. 60. Sine is positive in this quadrant, and positive in this quadrant. Sine of 480, so I'm going to take 480 and subtract 360. And that is 120. Guess what? That's square root of 3 over 2 again. Okay, now we remember all of these answers are square root of 3 over 2. Just subtract multiples of 360 or add them. If we take 840 degrees and we subtract 720, we get 120 degrees. So sine of 840 is sine of 120, which is sine of 60. Sine of negative 240. We just take negative 240 and we're going to add 360 degrees to it. Guess what we get? 120 degrees. Same answer.
You said 120 is 60. Is that just because sine is positive?
Yes, sine is positive in the second quadrant. And, you know, sine is, okay. Yeah, it's because sine is positive in the second quadrant. 120 is in the second quadrant. It helps to realize what quadrant you're into. Sine of pi over 3. Well, pi over 3 is the same as 60 degrees. That's square root of 3 over 2. All of these answers are square root of 3 over 2. We have 13 pi over 3, and we subtract 12 pi over 3. That's because that's 4 pi. I'm taking the angle and subtracting 4 pi. I get pi over 3. So sine of 13 pi over 3 is the same as pi over 3. I don't know why. I saw this pi over 4 down here. Okay. All right, so it's the square root of 3 over 2. And then you can add 2 pi to the minus 5 pi over, if you add if you take minus 5 pi over 3 and add 2 pi, and that would be 6 pi over 3, and you get pi over 3. So you're taking sine of pi over 3 again. All right, how do you find this in your calculator? We're going to use a calculator. If we want to find the sine of pi over 4, the first thing to do is set your mode to radians. Sine, okay, pi over 4, it's second caret pi. Second caret sign is pi divided by 4, enter. This is what we're going to enter in the calculator. So, the calculator. So you have one. So, you have to have your mode set to the correct thing. If it's degrees, set it to degrees. If it's radians, set it to radians. Otherwise, you get the wrong answer. So bring the calculator up. Second quit. Clear. So, mode, it's in degrees. I need it in radians. So I hit enter. I have to change it to radians. Second quit. Now we want to do sine, so we press the sine button. and we press second caret to get the pi, and then press divided by 4, and then we can close the parentheses, or calculator will close it for you, and that's what we get. And we'll go ahead and write down 4 places, 0.7071. Oh, you can't see that. Okay, how do you find cosecant? Well, there's no cosecant button on the calculator. So you have to remember that cosecant is 1 over sine. It says 1.5. There's no degree symbol, so you need it in radians. No degree symbol means it's in radians. So leave it in radians. Do 1 divided by sine of 1.5. The 4 places, it's approximately 1.0025. Okay, so that's how you use your calculator. Make sure you're in the right mode. That's the end of 4.2. But I did go slower. All right, I'm going to stop this.